This is a flywheel. It's attached to your engine. This is a clutch and it is attached to your transmission. Now let's imagine that you are at a standstill with your vehicle. In that scenario, you are in neutral and your engine is idling at, let's say, 800-ish RPM. Now let's imagine that you want to take off. So you're going to press the clutch pedal in, you're going to shift into first gear, and then you are going to gradually release the clutch to ensure a smooth takeoff. Why must the clutch be released gradually? Because what the clutch does is that it synchronizes the speed of the transmission to the speed of the engine. If you were to suddenly just let go of the clutch or dump the clutch, you would expose your entire drivetrain to all of the torque produced by the engine. You and your passengers are going to do like this. The drivetrain gets a nasty shock, the engine probably stalls, nobody's happy. But when you release the clutch gradually, you allow the transmission to gradually catch up to the speed of the engine. What we must ask ourselves at this point is, how does a clutch perform gradual speed synchronization? As you can see, it's just a solid object. There's nothing special about it. It does have these little springs, but all they do is that they absorb some of the shocks and the vibrations, and their capabilities are very limited. Because it's a solid object, the only way that a clutch can perform gradual speed synchronization and prevent shocks is by slipping on the flywheel. Clutch slipping is essentially a difference in speed between the flywheel and the clutch while the two are already in contact with each other. Clutch slipping occurs whenever the friction force between the clutch and the flywheel is low enough to be overcome by the torque produced by the engine. The friction force is determined by the clamping force, or how hard we press the clutch onto the flywheel. This clamping force is produced by the pressure plate, which is exactly what you're directly controlling with the clutch pedal and your foot. It is very important to understand that when clutch slipping occurs, the contact surfaces of the clutch and the flywheel are already touching each other. There is friction between them. The surface imperfections or asperities have started digging into each other, but they haven't yet dug deep enough into each other, and so the resulting friction force is lower. The torque of the engine overcomes this superficial contact, some of the peaks of the asperities they get torn off, and the surfaces slip on each other. This continues until the clamping is strong enough to force the surface imperfections to dig into each other fully. This creates a friction force that is higher than the torque produced by the engine, and so the clutch and the flywheel remain locked together until we separate them again using the clutch pedal. So clutch slipping is necessary in order to ensure a shock-free communication between the transmission and the flywheel. Although necessary, it causes clutch wear. As you have seen, we are constantly tearing off microscopic pieces off the clutch and turning them into dust. But this process is slow, and so it takes quite a bit of time to actually wear out the clutch. Much worse than this gradual wear is the heat produced by clutch slipping. If you have ever slipped a clutch too much, you have probably caught a whiff of this very characteristic smell. Just like new cars have a smell, so too do new drivers. It is the smell of a burning clutch. Clutch slipping is essentially the rubbing of two surfaces together. As you know, the friction between two rubbing surfaces, it creates heat. So if we rub or slip the clutch too long onto the flywheel, we are eventually going to increase the temperature so much that the clutch starts burning. When this happens, the surface of the clutch starts to melt. Sharp, pointy asperities turn into a smooth, glazed surface, which eventually becomes unable to grab and hold onto the flywheel. But what if we want to slip the clutch and keep slipping it without burning it? Well, that's actually easy. all you have to do is sink it in oil. And that's exactly the situation we have in a motorcycle clutch. Of course, here we don't have the space for one big clutch plate. Instead, we use a clutch pack composed of multiple smaller plates. But the function is the same. The beauty of a wet clutch is that it's very difficult to burn it. Even if you have very little clutch skill or finesse, you can keep slipping it continuously and repeatedly, and there will be no nasty clutch burning smell. Of course, that happens because the oil cools down the clutch. The same oil that circulates through the engine also circulates around the clutch pack. It takes away heat, it stabilizes the temperature, and it prevents burning. The added bonus of the oil is that oil is great at absorbing shocks, vibrations, harshness, noise, and so wet clutches are overall nicer and more pleasant to use than dry clutches. And also, they don't feel horrible when you continuously dump the clutch. Now, let's say that we want to step things up even further. Let's say that we want to keep the ability to slip the clutch without burning it, but at the same time we don't want to do the clutch slipping ourselves. And we want lightning fast gear shifts from one gear to the other in 8 milliseconds. No problem. Enter the dual clutch transmission, or DCT, or if you're a Volkswagen person, the DSG, or direct shift gearbox. A DCT is essentially your standard geared manual transmission, but with 2 wet clutch packs and 2 input shafts, and it has mechatronics and actuators instead of a clutch pedal. You shift with steering wheel pedals or a stick if you want to, and computers do the rest. The idea is to provide a lot of the exhilarating driving experience of a manual, so to let you be in direct control when and if you want to, and to combine all of that with all the convenience of an automatic. A dual clutch transmission can shift gears faster than any human can shift any conventional manual because it has 2 clutch packs. When you are in any one gear, one of the clutch packs and one of the input shafts is used, and that clutch pack that is used is engaged. The other clutch pack is disengaged, but its input shaft already has the next gear pre-selected. So when you shift from one gear to the other, the only thing that happens is that one clutch pack is disengaged while the other clutch pack is simultaneously engaged. That takes only 8 milliseconds. There's no actual gear speed synchronization or gear shifting when you go from one gear to the next. That occurs while you are already in gear without you noticing it. Okay, so it's the perfect transmission. Well, of course, that's very subjective, but a dual clutch transmission does accomplish its mission. There's a fun factor, but at the same time, it's super smooth, very convenient, very easy to use, and it can handle very high torque. The only downside is that it's more complex, it's more expensive, and it requires more maintenance than a conventional manual transmission. And this is because every clutch needs to slip. When it slips, it wears. When it wears, it loses tiny particles. These particles end up circulating in the oil. This is why, for example, motorcycle oil gets so dirty so quickly. It's the clutch particles. And so the oil and the oil filter of a dual clutch transmission must be changed much more frequently than the oil in a conventional manual. Some manufacturers will even tell you that the oil in a conventional manual never needs to be changed. That's a bit debatable, but it's not the topic of this video. What I'm trying to say is that the story should have ended here. We made the dual clutch transmission. You may or may not like it, but it offers a combination of benefits and drawbacks that makes it very suitable for a certain percentage of buyers. My opinion is that it's a very nice and interesting option to have on the market. But here's the problem. When manufacturers make something nice and something that sells, they always tend to ask the next question. And that question is always, how do we make more money from this? So enter the dry dual clutch transmission. The answer to that very question. Manufacturers will tell you they introduced dual clutch transmissions with dry clutch packs because they are more efficient. And Indeed they are, because the clutch pack isn't rotating in oil, there's no oil drag on it, instead it rotates in pure air, so it has an easier time rotating, and that contributes to an efficiency improvement of anywhere between 1 to 3%. Because the vehicle is more efficient, it needs to use less fuel, so dry clutch pack DCTs are better for the environment. Well, yes, but that depends entirely on your perspective, because he who gets to determine what gets measured also gets to decide what is dirty and what is clean. In reality, dry DCTs are not more environmentally friendly. The only thing they do is that they trade one type of emission for a different type of emission, a type of emission that has a more direct negative impact on human health. Yes, they do reduce CO2 by 1 to 3%, but they also dramatically increase particulate matter. That occurs because the dry clutch pack is not sealed. It needs to be cooled by air, so it needs to have ventilation holes for that air to enter and exit from the space of the dry clutch pack. Also, the dry clutch pack wears, so it creates clutch dust, and that clutch dust then comes out through those ventilation holes and into the air we all breathe. A wet clutch pack, in contrast, is sealed, and as it wears, the clutch dust gets trapped in the oil gets changed, and hopefully correctly disposed of. The negative impact on air quality is sadly not the only drawback of dry clutch packs. They also negatively impact your wallet. This occurs because every clutch needs to slip. At the same time, the relationship between the friction coefficient, clutch slipping, clutch temperature, and clutch wear is never simple and linear. No matter which of these two variables you relate to one another, you're going to get a complex curve on your graph. Also, clutch slipping is still one of those tasks where a human is better than a computer and software. And that's because a human has his or her eyes hopefully directed to the outside traffic. They can observe events as they happen, and they can react preemptively to prevent driving discomfort and drivetrain wear. On the other hand, a computer gets data through sensors which pick up data from the vehicle. But for them to pick up data and send to the computer, the event producing that data first must occur. And that means that a computer can only respond to events after they have occurred. Also, humans can naturally adapt progressively to a change in the clutch bite point as the clutch wears or some other conditions influence it. On the other hand, a computer must be often readjusted or recalibrated once wear or other factors get outside the parameters that a computer can control. When we combine this with the fact that a dry clutch pack obviously has no oil in it to maintain a stable temperature, absorb vibration, and increase the margin for clutch slipping error, we realize that a dry DCT has a much smaller window when it comes to dialing in just the right amount of clutch slipping to ensure a smooth operation. And so in the real world, we end up with a transmission that is much more prone to juddering and shaking and is simply overall harsher, noisier, and less comfortable than its wet clutch pack counterpart. A dealership salesman will enjoy telling you how you're going to save money with a dry DCT because it requires less frequent oil changes. In reality, it's going to cost you more in the long run because the clutch packs don't last nearly as long, the transmission itself is going to require more frequent calibration and readjustment while providing less user satisfaction and an overall shorter lifespan. The only place where a dry clutch pack is necessary is the highest level of two-wheeled motorsport. Here, we remove the oil from it so it spins easier, and that frees up maybe a fraction of a horsepower, maybe 2, doesn't really depend on the motor. But here, every little bit of power matters, so here we can justify the drawbacks of a dry clutch pack. But even companies like Ducati that used to offer mass-produced motorcycles with dry clutch packs, they don't do it anymore because for 99% of the buyers, it really doesn't make sense. Yes, it sounds kinda cool, it is kinda cool, it's that motorsport racy thing, but that's the only benefit, and it's not really a functional benefit, while you do get functional drawbacks. Dry DCTs in cars were introduced as early as 2007. In the beginning, they were pretty few and far in between, but as time moved on, more and more manufacturers introduced more and more models, and now they're a pretty common choice on the car market. In the beginning, some units were pretty unreliable. As time moved on, some became better and more reliable, but the sad reality that remained is that the equation of benefits and drawbacks of a dry DCT is stacked against the buyer and in favor of the manufacturer. A dry DCT is cheaper to make because it requires less parts, you don't need to seal the clutch pack, you don't need an oil pump and an oil return to circulate the oil through it, and so on and so forth. While at the same time, it allows manufacturers to meet emissions regulations more easily. Dual clutch transmissions also lend themselves well to hybridization. Because they already have a rotating flywheel, it's pretty easy to integrate electrical components, such as a rotor and a stator, into the drivetrain. This is great for manufacturers because it allows them to keep using existing technologies they have already invested millions in developing. But the final cost is again borne by the consumer, because now replacing and/or servicing those electrical components requires specialized tooling and removal of the entire transmission to gain access. So there you have it. You want your belts dry and your clutch packs wet, especially if you're buying a used car. As always, thanks a lot for watching. I'll be seeing you soon with more fun and useful stuff on the D4A channel.